Alright, testing. Alright, we're recording now. Alright, Department of Energy Fundamental Handbook, Instrumentation, and Control Module. Oh, shit, I lost it. Alright, Module 7, Process Controls. Principal control system. Introduction. The instrumentation provided with the various induction indicate that you the proper to operate with the nuclear facility. In some cases, the operation record with the indicate that you the day-to-day operation facility. The information recorded with the help of the operator to evaluate the current condition of the system and takes action with the condition. Do not expect the procuring operator to take all the required corrective action. Impractical, sometimes impossible, especially with a large number of the indicators that must be mindful of the region. Most of the system controlled by automatically once by the operating under normal condition, automatic control will greatly reduce the burden of the operator that makes his or her job manageable. Process variable the requirement of the control system include but not limited the flow level, the temperature, the pressure for the system do not require. All these process variables will control the thing of the central heating, the basic heating system, the operating for the temperature, disregard of the other atmospheric parameters for the house, the thermostat monitors, temperature for the house, the temperature drop of the value of the select of the occupants of the house, the system activated the rate of the temperature of the house, the temperature of the reach of the desired value of the system turned off. Automatic control system neither play for the near leave of the operator of the responsibility maintaining the facility. The operation control system is periodically checked with the verify the proper operation of the control system failed. The operator must be able to take over control of the process manually, with most cases understanding how the control system works and able to operate to determine the system operation properly with which actions required to maintain system in a safe condition. Terminology for the control system, the specifically integrate with the elements of each function for the maintain with the process variable with the desired variable within the desired range of the control system, mind with the process variable for each call the sum of the action that could the maintain the desired system parameter, the example of the central heating of the system, mind with the temperature for the house, and give the thermostat with the temperature for the house, drop the preset value with the furnace terms off, the provide with the furnace terms down, the provide the heat over the temperature of the house, encrypted until the switch for the thermostat cover the furnace to turn off. Two terms which help to define the control system, the input and output of the control system, input the system simultaneously apply with the control valve system external source of the polarity for the specified response for the control system and K for the central heating unit. The control system input with the temperature of the house is monitored by the thermostat. The control system output with the actual response they obtain with the control system. The example above with the temperature of the drop of the preset of the value. Thermostat cover the furnace to turn on and off provide with the heating and rate of the temperature of the house. The incapable of the nuclear facilities in and output with defined with the purpose of the control system. The knowledge of the input of the output control system enable the components of the system identified with the control system and have more than one input and output. The control system classified with the control action which with the client with the response with the activating the current controls if the output with the two general classification open loop with the closed loop system. The open loop system is one with the control switch for the independent output with the end. An example of the open loop control system is chemical addition pump with the variable speed with the control of the feed rate with the chemical with the maintain with the proper chemistry with the system determine the operator with the not part of the control system. If the chemistry with the system and the chain with the pump cannot respond with the adjusting the feed rate with the speed without operator action. The chemical storage tank with the end of the chemical addition pump the chemical to the system and pump the speed control signal. A closed loop system is one with control action that's dependent on the output of the figure 2 show with the example of a closed loop control system. The control system to maintain with the water level of the storage tank with the system prevent the task to continue with sense of the level of the tank adjusting the supply volume. The ability to add more or less water with the tank at the desired level is reset by the operator who is not in part of the system. Supply tank with the level of control valve with the water tank with the water level of the water tank level of demand by the system level of transmitters level of signal level controller control signal feedback with the information of the closed loop control system condition of the possible variable compared with the desired condition produce the proper control action of the process information continually with the feedback with the control circuit with the respond with the control action and previous example the actual storage tank of the water level the same level transmit with the feedback with the level control feedback with compared with the desired level of the required control action will position with the level control needed to measure maintain desired level of figure 3 show the relationship figure 3 show the feedback and closed loop control system the corrective action control signal level of control valve of the water process water storage tank feedback actual tank level the control system level controller desired tank level. Automatic control system preset closed loop system that require with no operator with the action with the assume with the process will remain with the normal range with the control system. The automatic control system has two powerful variables associated with the control variable, the manipulated variable. Control variable, the process variable to maintain the specific value within a specified range. The previous example, the storage tank level, the control variable, the multiple manipulated variable, the process variable, the active with the control system maintains the control variable specific value within the specified range. The previous example, the flow rate with the water tank supplied by the tank of the manipulated variable. Functions of the automatic control. The automatic control system, four basic functions that occur with the measurement, comparison, computation, correction. In the water tank level of the control system, example above the level of the transmitter becomes the level within the tank. Level transmitter, some of the signal represented the tank level to the level of the control device, where they compare with the desired tank level. The level of the control device computes how far they often supply the value with correct the difference between the actual and desired tank level of the elements for the automatic control valve. Automatic control. The three functional elements that perform the function for the automatic control system are the measuring element, the error detection element, and final control element. Relationship between the elements and function of the perform the automatic control system is shown in Figure 4 for the measurement element, perform the measuring function for the sensing for the evaluating control, verify with the error detection element, first compare with the value with the compare control variable, the desired value, the signal and error of the and deviation exists for the amount of the actual desired value of the final control element, respond to the error signal by the correcting manipulated variable of the process. This shows the relationship of the function elements for the automatic control system, input with the final control element with the process of disturbance for this, and then back to the measuring elements, measurement, and compare, error, detect the comparison, desired value, computation, the input, input to output is called the automatic control system. Feedback control, automatic controls error sensitive to the self-control device that takes a signal from process feeds it back into the process. Therefore, the closed loop control system is referred to as the feedback control. Some of the basic principle of the control system summary is below. The control system is the system that integrates with this element whose function is to maintain process variable, the desired variable, with the desired range of value. The control system is similarly applied with the control system for the external system or to produce specified response for the control system. Control system output, actual response obtained with the control system. Open loop control system. System one of the control actions independent of the output of the closed loop. System one the control of the dependent on the output of the feedback information closed loop system about the condition of the process variable, the condition variable, the process variable to maintain the specified value within the specified range. And manipulated variable, the process variable acted upon with the control system maintained with the control variable with the specified value within the specified range. Control loop diagrams. Terminology. Block diagram of the pictorial representation cover the effect of the relationship between the input output, the physical schematic with the physical system. The block diagram is provided with the means that is easily identified with the functional relation among the various components of the control system. Simplest form of the block diagram, diagrams. It consists of a single block, one input with one output. Figure 5A with the block normally contained with the name of the element. Figure 5B with a symbol of mathematical operation. 5C with the perform the input with the obtain with the desired output. Arrow with identify the direction input, information, or signal flow. Show the input block and the input with the control element, output, and x over the square root with the equals y equals over the square root of x. Although the blocks are usually identified in many types of mathematical operations, the addition of the subtraction represented with the circle in summing point with the shown in figure 6 with the summing point with the having half with only one, and show the input with each of the input with the appropriate pole plus or minus second sign with the summing point. There's only one input, only one output with each equal to the algebraic sum of the inputs. And show the summing points. Takeoff point is usually allowed the signal to be with more than one block of the summing point. Figure 7. Takeoff point show the A and A, B, and feedback control system schematic with the block diagram. Figure 8 show the basic element feedback control system represented with the block diagram. Functional relations between these elements are easily seen with the important fact of the remember the block diagram represents the flow path control signal that does not represent the flow energy with the system of the process. You have reference endpoint set point positive and negative actuation points control elements manipulated variable distributions plan control variable output also the control variable output the feedback symbol back to the reference endpoint set point. Alright, below are several in terms of the associated with the closed lock loop diagram of the plan, the system, and the process with the particular quantity of the condition of the control that is off the call with the control shift, the control elements component with the identity of the generator, the appropriate control signal applied by the plane with these elements are off the call with the control of the feedback elements components need to identify with the functional relationship between the feedback signal and the control output, the reference point, external signal applied with the starting point with the control system cover the plan to produce the specified action signal represented with the desired value with the control variable, the also cover the set point with the control output with the quantity condition of the plan which is controlled signal represented with the control variable, the feedback signal is a function out with the output signal that is sent with the summing the point with the algebraic to add with the reference input signal to obtain the actuating signal represented with the controlling action control loop is equal to the algebraic sum of the reference input signal, the feedback signal. This is also called the arrow signal manipulated variable, the process actuated acted upon to maintain the plan with the output with the control variable desired value. Disturbance is undesirable input with the upside with the value with the control of the output with the plan with the figure 9 show for the typical application block diagram and identifying the operation of the temperature control system of the lubricating oil. A and figure 9 show the schematic diagram and lube oil control cooler associated temperature control system. Show the hot oil and the cold water loop oil with the cold oil output, the temperature control valve, water warm output, the temperature transmitter, temperature control controller set point, and then the setting reference point, air signal, the temperature control, actuating signal, the temperature control valve, cooling water flow rate, manipulated value, variable loop oil, coiler loop oil, temperature control output, the temperature transmitter, feedback signal back to the set point, reference input. Alright, lubricating oil reduces the friction between the moving parts of the mechanical valve, remove the heat from the components, the dissolve the oil becomes hot, the heat, remove the loop oil with the cooler, prevent the bolt breakdown of the oil damage to the mechanical components, and serve the loop oil cooler can dip the hollow shell with the tube with the running through it, the cooling water flows inside of the shell of the cooler, around the outside of the tube with the loop oil flows inside of the tube of the loop when oil never to become physical contact. The water flow through the shell side of the cooler that picks up the heat from the loop oil through the tube with the cools loop oil with warm and cooling water is level the cooler. Loop oil measure to maintain the specific operation band with the ensure the optimum equipment to perform with the accomplish with the controlling flow rate with the cooling water with the temperature control loop. The temperature control loop consists of the temperature transmitter, the temperature control valve, the diagonally cross line with the indicator with the control signal air of the pneumatic. The loop oil temperature with the control variable to make cover the maintain with the desired level of the set point with the cool water flowing rate with the manipulated variable to be covered with the adjusted with the temperature control valve to maintain loop oil temperature with the temperature transmitter sends with the temperature of the loop oil leave with the cooler with the send with the air signal with the proportional temperature control with the next temperature with the control. You compare with the actual temperature of the loop oil set with the point with the desired variable. The difference that exists between the actual desired temperature of the control valve vary with the control air signal and temperature for the control valve. This color the move it in direction of the amount with the need with the correct with the difference for the example the actual temperature greater than set point with the control will vary with the control air signal will cover the valve with the movement in the more open direction. The result of the more cooling water flowing through the color lower temperature with the loop oil leaving the cooler. B in Figure 9, the representative of the oil temperature cool control loop block form diagram form. The loop oil cooler is planned with example of control output of the loop oil temperature for the temperature transmit the feedback element is sent for the control output of the loop oil temperature produced the feedback signal. The feedback signal is sent for the summing the point with the algebraic average the reference point with the set point with the set point signal with the positive feedback signal is regularly means the resulting actuating signal with the difference between the set point and the feedback signals. The actuating signal process passes for the two control elements, the temperature control and the temperature control valve. The temperature control valve responds with the adjustment of the manipulated variable, the cooling water flow rate, the oil, the temperature change, the response, different water flow rate and control loop is completed. Or your process time lags. In the last example, the control loop oil temperature of the initially may easily apparently the operator would need only the loop oil temperature compared to the actual temperature of the desired set point with the compute amount with the air, if any, with the temperature control valve with the accurate or air accordingly have with the process of the characters delaying with the retarding chain with the value of the process of the variable the characters generally increase the difficulty of the control. Process time lags in general time that describe the process of the delay and the retardation process of the time lag with the three properties of the profit, the capacity, reaction, the transportation time. Capacity is the ability with the profit, the storage energy with the Figure 9 of the example of the wall, the tube with the loop oil, cooling water, loop oil storing heat energy. This energy stored with the property you give the ability to retard the chain with the cooling water flow rate with the increase with the take with the period of the time. More energy to be removed with the loop oil to reduce the temperature. Resistance to the profit, the with the transfer of the energy between the capability of the Figure 9 wall with the loop oil cooler opposite with the transfer of the heat with the loop oil inside of the tubes of the cooling water outside of the tube. The transportation time of the required with the carry the chain with the process of the variable with one point with another profit. The temperature of the loop oil is lowered. Increase the cooling water flow temperature rate with some time with the left the loop oil travel through the loop oil cooler. Temperature transmit the transmitters move through farther through the loop oil cooler than the transportation time will increase the time lag, but it's not just the slowdown and the retardation of the change, the actual time delay during the normal change, no change occurs. Or your stability of the automatic control system. All controls previously described and can return the process variable steady value following the disturbance of characteristics is called stability. Stability is the ability of the control loop to return the control variable to stay with the non-cyclic value of the following distribution. Control loops can either be stable or unstable and unstable to cover the combination problem of the time lag discussed earlier in the capacity, reactions, transportation, inherent time lag, the control system, the result of the slow response chain with the control variable. Consequently, the control variable will continuously cycle around the set point value. The oscillation described with the cycle occur. There are two types of oscillation. They occur with the control loop, the decreasing amplitude with the constant amplitude, the increasing amplitude, each shown in Figure 10. Decreasing amplitude with the oscillation of Figure 10A, the decreasing amplitude eventually stop with the control system above the chain with the control variable. These conditions describe the desired automatic control system. A show with the decreasing amplitude, B show with the constant amplitude, and also the C with the increasing amplitude. Constant amplitude, Figure 10B with the active with the control of the suction, sustains the oscillation with the control of the variable will not with the E with the disable the condition, therefore the condition is not desired. Increasing amplitude, Figure 10C. The control system is not only used sustaining oscillation, but also the increase the control element that reaches the full travel limits that cause the ends of these processes to go out of control. Alright, some of the important parts of the information for the chapter are summarized below. Control loop diagram summarized. Control loop system with the system of prophecy with the quantity, with the condition, with the control elements, component with the need that you can generate the appropriate control with the signal applied with the plane with the elements for the conflict element, the control of the feedback elements, component with the need to identify the functional relationship between the feedback signal with the control element, the defense point with the external signal applied with the harmony point with the control system and the call with the plant to produce a speed is specified action. The control output with the quantity of the condition of the plant will be controlled with the signal respond with the control variable, the feedback signal with the function of the output signal with the same with the assembly of the algebraic add with the reference input the signal obtained with the actuating signal with the actuating signal the reference with the control act for the control loop with the equal algebraic sum of the reference input signal the feedback signal. This is called the error signal. The manipulated variable, the variable properly acted upon with the maintained plant output for the control variable. The desired value distribution is undesirable. The input signal the upset value of the control output with the plant process time lag is affected with the capacity with the ability to profit the stored energy resistance. Perform the process opposite with the transfer of the energy of the between the capacity of the transfer time and the time required to carry the change in process variable to one point to another and profit the time and the lag with not just the slowdown with the change rather than the actual time delay during the no change occurs. Alright, two-position control system. The controllers device to generate the output signal based on the input signal to receive the input signal, actually the error signal, which is the difference between the measure of the variable the desired value set point. Input error signal represents the amount of the deviation between whether the process system actually operating with where the process system is desired to be operating the control provided the output signal to the final control element that would adjust the process system to reduce the deviation of the character of the output signal depending on the type of the mode or the mode of the control of the chapter described the simplest type of the controller, which is a two-position on-off mode controller. Figure 11 shows the process control system, the cold oil in the control valve, hot water in the temperature control set point, temperature transmitter, the heat out oil, cold water out, heat exchanger, measure variable. The controller has the summing junction error in the control action set point with output control valve. Two-position controller. The two-position controller is a device that has two operation conditions, completely on or completely off. The show with the figure 12 to show the input-output characters of the waveform. The two-position controller with the switch for the off, with the shape with the on, with the shape with the measure variable to increase the below with the set point, with the conversely with the switch and the on shape with the off shape with the measure for the variable degree. For the below the set point, the device measured provides output to determine whether the error signal is above or below the set point, the magnitude of the error signal is below the set point, the magnitude of the error signal that pass to the point that is not concerned with the controller. The output and on and off the set point measure variable. Two-position controller input-output relationship. For example, the two-position controller set system uses the two-position controller set as shown in figure 12 to 213. Show that the two-position control system, water in gate and the LC, the LT, the tank of the water output. The control process for the volume of the water tank of the control variable, the level of the tank with the measure for the level to send the information for the control of the output of the controller step with the final contact and element of the solenoid valve with the control of the flow of the water into the tank. The water level to decrease and initially the point with the reach for the measure for the variable to drop with the level of the set point create with the positive of the air, signal the control open to the final control element of the water is subsequently injected with the tank with the water level arrive as soon as the water level arrives to the above of the set point with the negative error signal is developed, the negative error signal cover the control of the shut the final control element off. The opening and closing of the final control element result of the cycling characteristic measured variable. The motives of the automatic control. Mode of control of the manner of the control system and the make of the correction the relative of the error of the exit between the desired value with the set point with the control variable, the actual value of the mode control will use the specific application depends on the character of the processing control. For example, some of the process can be operated with a wide band while others must be very close to the set point. Also, some of the process change relatively slow without other change almost immediately. Deviation of the difference between the set point of the process variable, the actual value. The key terms used with the discussion of the various modes of the control, the four modes of the control commonly used the most applications are proportional plus reset, proportional rate plus rate, and proportional plus reset plus rate. Each of the control characters with advantage of the main limitation of the mode of the control discussed in the next several sections of the module. The proportional throttle mode. There is a continuous linear relation between the value of the control variable with the position final control element. In other words, the amount of the value of the moment is proportional amount of the deviation. Figure 414 shows the relation between the value of the position of the control variable, the temperature character with the proportional mode of the denoted for the value of the position change with the exact proportional deviation proportional mode represented responding to the amount of the deviation or incentive of the rate of the duration deviation amount 2 minutes and 4 minute mark with the temperature return with the set point value with the value of return to the initial point of no value correction without deviation. Show that the increase is on the left and then the time 1, 2, 3, 4, 5, 6 intervals. At the top you have your wide band, narrow band while positioning in initial position, deviation, temperature, set point. The three terms commonly used are the proportional mode with the current with the proportional band gain and offset. Proportional band is also called the throttle range of the chain with the valve with the control variable with the full travel the final control element. Figure 14 shows the relationship of the valve position temperature band with the two different proportional bands. The proportional band particular instrument exposed with the percent with the full range for the example. Full range of the instrument with 200 degrees Fahrenheit is take a 50 degrees Fahrenheit chain with the temperature cuff with the valve with the travel with the percent proportional band. 50 degrees Fahrenheit and 200 degrees Fahrenheit is 25% proportional bands. May be the range with the 1% with the 0 to well over 200%. Over the proportional bands over 100% cannot cover the fully valve travel even with a full range of the change of the control variable. Gain is also called sensitivity compared with the rate of the amount with the chain of the final control element amount of the chain of the control variable to mathematically gain sensitivity reciprocal proportional band. The offset also called the droop of the deviation remains after the process of the stabilized with the often set with the inherent character of the proportional mode of the character control. In other words, proportional mode of the control will not necessarily return the control variable to a set point. Summarize the important information chapter summarized below. Alright, you have your two-position control summary with the device with the two operating condition completely out of the device, provided the output with the determination while the error signal is in above the below the set point of deviation difference between the set point of the process of the variable actual value with the proportional throttling mode with the amount of the value movement with the proportional amount of the deviation gain with the compressed with the ratio of the amount with the gain and final control element of the chain with the control variable and offset of the deviation remains after the process has been stabilized. Proportional control systems. The control mode. The proportional control mode with the final control element of the throttle with the various proportional position dependent with the process system. Point addition, for example, the proportional controller provides the linear step list with the output with the can position for the valve with the intermediate position as well with the full open, full shut. Control operates within the band between the 0% output point and the 100% output point where the output with the controller is proportional input signal and proportional band. Proportional control with the final control element, the finite position with each variable, the measured variable. In other words, output with the linear relationship with the input with the proportional band chain with the input required to produce the full range chain with the output to the proportional control action simple and percent chain with the input signal required to chain with the output signal 0 to 100%. Proportional band with determines the range of the output variable from the controller operating the final control element. The final control element acts on the manipulated value to determine the value of the control variable. The control variable is maintained with a specified band with control points around the set point to demonstrate the look at the figure 15 example. The proportional level of control system flow supply from the water tank into the water tank controlled by the maintained tank water level the prescribed and limited the demand of the disturbance to be placed in the process system as such. Figure 15 shows the proportional system of the controller, water in, water out, your tank gauge and gate. The actual flow can be predictable, therefore the system is designed with the control thing level to narrow band with an order to minimize the chance of the large demand. The distribution to the cuffing overload run out with the fulcrum in the left of the assembly of the U with the proportional control of the flow chain with the level of the measuring element of the 4-inch stroke valve with the final control level of the element. Fulcrum point and start with the level of the chain with the 4-inch cover with the full 4-inch stroke with the valve with the layer 4, the 100% of the chain with the control output equals the 4-inch of the proportional band. Input band over the controller provided the proportional output of this design is proportional band is equal to the percentage change to input over the change in output times 100%. For example, the fulcrum point of the 4-inch chain with the float type with the cover with the 4-inch stroke with the proportional band is 100% change input over the 100% change output times 100 or proportional band equal to 100%. But the controller of the proportional band 100% of the mean for the input chain with the 100% of the cover with the 100% chain with the output with the controller. If the fulcrum setting was chain with the level of the chain with the 2-inch for the 50% of the input cover with the full stroke with the 3-inch for the 100% output, the proportional band would become 50% with the proportional band. Proportional controller input would determine the range for the output for the given input. Example, the proportional process control system figure 16 illustrates the process system and using the proportional temperature controller for the providing hot water. Alright, so for the cold in water, the system and the set point 150 degrees proportional band, 50% heat exchanger, hot water steam output. Controller output on the left is 0 to 150, 100 degrees Fahrenheit, 50 degrees. Proportional band, measured variable, change in Fahrenheit. Steam is emitted with a heat exchange with the rate of the temperature for the cold water supply with the temperature defective amount for the hot water outlet with the 3 to 15 psi output signal representative of the control variable the range with 100 to 300 degrees Fahrenheit. The control compared with the measure of the variable signal the set point with the 3 to 15 psi output with the final control element with engine 3-inch control valve. The control has been set with a proportional band 50% with therefore 50% of the chain with the 200 degrees Fahrenheit with the span with the chain with the 100 degrees Fahrenheit with the cover with the 100% control output chain with the proportional controller with the reverse action of the control valve. Throttle demand of the reducer stream the outlet water outlet temperature increase the control valve with the weather with it further the increase the stream of the water temperature decreases. The combined action of the control and control valve the different chain with the measure with the variable shown in figure 17. Measurable variable control output, the control valve position 100%, decrease 12 psi, decrease out 100%, out span 100 degrees Fahrenheit, out 50% input, span 50 degrees, 25% input, span 60 psi, increase 50% output, span 50% increase, time interval 1 and 2. Initial measure value of equal to the 100 degrees Fahrenheit. The controller has been set with the available measure variable to correspond 100% output with a 15 psi would in turn correspond with the full open control valve position. At time interval 1, measure the variable to increase the 100 degrees Fahrenheit with 50% of the measure variable, span with the 50% of the controller, input with the chain with the cover with the 100% controller output change with the controller proportional band at 50% of the direction of the controller output change is decreasing because of the controller's reversing action. 100% of the decrease correspond with the decrease of the output of the 15 psi with the 3 psi, which can over the control valve to go fully open and fully shut. At the time interval 2, the measure variable to decrease with the 50 degrees Fahrenheit, the 25% of the measure variable span with the 25% with the controller input, decrease with the 50% with the controller output, increase with the result when the controller output decreases 3 psi, the 9 psi control valve go through the fully shut with the 50% of the open. Proof that the system provided the hot water set point at 150 degrees, but the system must be capable of handling and disturbance can result with the outlet temperature with the decrease of the set point with the reach for the controller set up within the system function shown in Figure 5.18. Figure 18, controller output 3 psi, 9 psi, 15 psi, 100 degrees, 150 degrees, 200 degrees Fahrenheit, measurable variable, set point error, measurable variable to do after the set point with the positive error to develop the control with the valve to open, third of the measure variable to go above the set point, negative error is developed the control valve throttles down, opening and reduce with the 50% proportional band cover the full stroke valve to open between 50 positive 50 degrees Fahrenheit and error of negative 50 degrees Fahrenheit. Error equal to 0 with the control power level to 50% of the 9 psi against signal control valve. The error will go to the valve below the point of control produced with the output, but that is in proportional magnitude of the error. Determine the value of the proportional band of the control valve the capable of being positioned with the compensate with the demand of the disturbance that can cover the process of deviate the set point in either direction. Your summary. In the information chapter of the summarized below with the proportional control summary of the proportional control mode, the final control element, throttle, the various positions depending on the process of the system conditions, with the proportional control of the output with the linear relationship of the input and the proportional band and chain of the input required to produce the full range of the chain of the output to do with the proportional control action. The control the variable to maintain with the specified brand with the control point around the set point. All right, your reset integral control systems. They reset control integral. The integral control that describes the control of the output range of the chain with the independent of the magnitude, the input with the specific smaller amplitude, the input with the cover with the slower rate of the chain with the output with the controllers cover the integral control to be covered the approximate. It's over the mathematical function integrated the integral control method is known as the reset control. Definition: integral control. The device to perform the mathematical function integration, but they cover the integrated with the mathematical result of the integration. They cover the integral with the integral integrator with the provided the linear output with the rate of the chain with the directly related the amplitude with the step with the chain with the input with the constantly specified with the function integration. For example, the shown in Figure 19, step with the chain with the amplitude, the 10% of the constant with the integrator cover the output chain with about 0.2% per second of each with 1% of the output. Input. The integrator acts for the transfer step of the chain with the gradually chain with the signal, as you can see with the input with the amplitude with the repeat of the output every 5 seconds. As long as the input remains confident, 10% of the output will continue to ramp up every 5 seconds until the integrator saturates. Show the input with a constant with a 0.2% over the SEC, the integrator output with the input with the integral output. The example of the integral flow control system, the integral control final control element position change with the rate determined by the amplitude of the input error signal. The recall of the error is equal to the set point minus the measured variable. The error large difference exists between the set point and the measured variable. The large error of the result of the final control element of the transition rapidly, but the only small difference exists with the small error with the signal will cover the final control element of the chain position slowly. Figure 20 illustrates the process with the integral control to maintain constant flow. Also, include the equivalent block diagram of the controller. Show the flow and control valve of the 3 to 15 psi integral control flow at set point at 50 gallons per minute, 40 to 20 MADC, the FT 0 to 100 gallons per minute flow out. This offers the set point with the integral controller constant 0.10 SEEC, negative 1 error control function, measured variable output control value. Initial system set up with the anticipated flow demand of 50 gallons per minute, the corresponding with the control valve with the opening at 50% of the set of the equal to 50 gallons per minute. The actual flow measured for the 50 gallons per minute zero error signal. Some of the input signal integral control of the control output with the initial set of the 50% with the N7 9 psi with the output position, the 6-inch control valve with the position 3-inch for the open the output range of the chain with the integral cover. The controller is given the output range for the integral equal to the integral constant a time with the 8% of the error, the measure for the variable, the decree for the initial value for the 50 gallons from the new value of the 45 gallons It begins from minute figure 21, positive error of 5% produced the amplitude with the input with the integral control of the controller accounts for the tenth of a second. The negative first, the stroke of the control output of the chain with the negative 0.5 tenths of percent per second. Positive 5 percent per second indicate the controller output and the initial point with the 50% with the 0.5 per second. They cover the control valve to open further rate of the 0.5 per second increase the system flow measured variable set and point error and control output the control valve position. The control acts on no return profit the set point with the accomplish for the reposition of the control valve. If the control cover the control valve reposition the measured variable to move the close to the set point. The new error signal is produced. The repeats itself until the new error exists. The integral can correspond to respond with both the amplitude with the time duration error signal. The sum of the error signal largely exists for the long period of time cover the final control element the reach for the fully open the fully shut position before the error is reduced to zero. If the curve of the final control element remains in the extreme position, the error must be reduced to other means actual operation processing system. The property of the integral will control the major value of the integral controller. They have the unique ability to return the control variable back to the exact set point with the following disturbance. The disadvantage integral code mode, but they respond with relatively slow with the error signal that it can initially allow with the large deviation the instant of the error is produced. This can also lead with the substantial system and its instability cycle operation. For the reason integral code mode is not normally used alone combined with the other controlled manual. The summary integral controller summary. The integral controller summary. An integral controller provided the output range of the chain with determined by the magnitude of the error and integral constant. With the constant controller, there is unique ability to return the process back to the exact set point of the integral controller made with not normally used by itself because it is slowly responsive to the error signal to an error signal. Proportional pulse plus rate control system. Proportional plus rate system. The type of the control, the action with the combination two previous control mode. The proportional integral combines two modes with the result of the game. The advantage for the compensating for the disadvantage for the two of the individual mode. The main advantage for the proportional control mode is the intermediate proportional output that produced is assumed with the error of the signal is good for the controller is shown in figure 222. Proportional controller is considered the fast acting by the immediate of the output chain with the essential enable the proportional controller response. Reposition of the final control element in the relatively short period of time in response to the error. The two figure 222 the response for the proportional plus reset. Error proportional only action current reset only action proportional plus reset action output. The main disadvantage of the proportional control mode is the residual offset of the error with the difference between the measured variable and the set point for all the one set with the system condition. The main advantage for the integral control mode with the control output is again to the reposition final control element of the error reduced to zero. The result is the elimination of the residual offset of the error allowed with the proportional mode. The main change of the disadvantage for the integral mode with the control output it does not immediately directly become final control element of the new position response for the error signal. The control of the output chain with the defined rate of the chain with the time need for the final control element to reposition combination two control modes to cover the proportional pulse reset with control mode. You're going to meter output chain with the character of the proportional control mode with the zero residual offset of the character for the integral mode. Example: the proportional plus reset control lets one refer to the one or heat exchanger. Example: figure 223. The time will apply with the proportional plus reset control. The process system cold water in control valve steam and the PI control set point hot water out like heat exchanger steam output. The response to the curve shown figure 24 illustrates the one of the demand measure for the variable to represent the hot water outlet. The temperature assumed the pressure is uninsured. According to the demand disturbance with the reduce the flow of the hot water output, the heat exchange with the temperature for the flow rate, steam with the heat exchange with the remain the same. With the result of the temperature for the hot water will begin to rise. The proportional action of the proportional plus reset controller is acting alone would respond with the disturbance position with the control valve position with the return of the hot water. The new control point with the illustrated response curve. You note that the residual error would still exist. So the demand, the measured variable with the control point for the offset with the proportional proportional only set point, the proportional plus reset set point. By adding reset action, the proportional action of the control provided the larger output of the given error, stick with the cover, the greater adjustment of the control level to this cover, the profit to come back at the set point back quickly, additionally reset the action with eliminate the offset error for the period of time. Your reset windup. Proportional plus reset control is active to eliminate the offset over the found proportional control of the cover. Continuing chain with the output of the proportional action complete with the return of the control variable to instead of the inherited disadvantage of the proportional plus with the reset of the control of the plus adversely affecting the cover with the large error signal the large error that can be caused by the large demand deviation with the initial starting up of the system problem because of the large sustained error signal eventually with the control to drive the limit. The result of it is called the reset windup. The reset windup into the control mode not well suited the process that are frequently shut down and started up. Alright, your summary. The proportional plus reset with control mode summarized below. Proportional plus reset control summary. The proportional plus reset control eliminates offset error would occur with the proportional control only. Reset wind up with an inherited disadvantage. Proportional plus reset controllers that are subject to larger error signals. Proportional plus reset control systems. Proportional derivative. Proportional plus rate. Discover the control method of the derivative. The section they add to the proportional control of the derivative. Section of the respond with the rate of the train. The error signal and the amplitude of the derivative. The action the respond with the rate of the train. With the instant with the start of the chop of the control unit output with the initial large with the direct relation with the error signal rate with the chain with the higher error signal the rate with the chain with the cuff. Soon with the final control element of the position with the desired level. The add of the direction. Derivative action reduced the initial overshot with the measured variable, therefore the aids in stabilizing the processes sooner. But the control mode then should call it the proportional plus rate with the or PD. Control the derivative section will respond with the rate of the chain with the error signal. Definition of the derivative control. Divide for the productive produce the derivative signal couple the differentiator. Figure 225 show the input with the various output with the relationship of the differentiator. The differentiator provided the output that is directly related with the rate of change with the input with the constant specified with the function of the differentiator. Derivative accounts with expressed with the units and second defined with the differential control output with the differential axis transform with the change signal the constant magnitude signal is shown figure 26. As long as the input range change with the account with the magnitude of the output with the constant of the new input rate change would be very give it the new output magnitude. Show the input with the constant of the two SECs differential output with the 10% of the input with the time interval 0 to 1 5 seconds, 4% time interval 5 seconds output. Controller input with the controller rate control output with the time interval 1, 2, 3, 4, and 5 time seconds. Derivative cannot be either alone with the control method. They should recover the same input with the receive the error output with the differential with the differential with either the control input with the signal would be receive the error signal with the describe the state of the error signal and respond with the any number necessary output signal with the position final control element. Therefore, the derivative the action combined with the proportional action the manner of the drive for the proportional section output serve with the derivative the section input. Proportional plus rate with the control with the take of the band for the both the proportional rate and control mode with the scene in figure 27 of the proportional action provided with the output of the proportional to the error. If the error does not stop, chain with the lowly chain with the proportional action is low. The rate of the action when added to quickly respond to the error. The error 0, 5, 10%. Proportional action 20, 30, 40%. For rate of only action 0 to 10%. Proportional plus rate output 20, 30, 40, 50%. Time interval was 0 to 1, 1 minute to 1 to 2, and 1 minute. Example, the proportional plus rate control. The illustrated proportional plus rate with control will use the same heat exchange with the process of the heat design with the previous chapter figure 28, for example, have with the temperature control with the proportional plus rate. Example, cold water and control valve steam rate 315 psi plus plate controller set point 315 psi hot water output the heat exchanger steam input steam output. It's illustrated in figure 29 with the proportional only control mode to respond with the degree of the demand with the pickup of the inner hair with the character with the proportional control the size will offset with the remain with the adding with the derivative action with the effect of the response with allowing with only one set small overshot with the rapidly stabilization new control point with the derivative action to provide with the increase with the stability with the system demands does not eliminate offset error. Figure 229 shows the effect of the distribution proportional plus rate reversing action controller. The demand, the measured variable, measured and variable. Control proportional on the online offset control point proportional plus rate offset and the time. Application proportional plus rate control with normally used with a large capacity with slow responding process such as the temperature control leading action for the controller output compensate with the low and character with a large capacity slow process with the rate action that is not usually employed with the faster respond with the process with low control noise with the process with the derivative action respond with the rate of change of the error signal including noise. The proportional plus rate controllers are useful to process with the frequency start up and then shut down to cover their non-suspectful reset wind up. Summary. The proportional plus rate control summary. The derivative action is added with the controller to make the response with the rate of the chain of the error signal. The derivative action cannot be with the control mode alone. With the proportional rate of the controller does not eliminate the offset error of the proportional plus rate with the control ease and create the system stability. Are your proportional integral derivative control systems? Proportional integral derivative. The possibility they can be operated with a continuous cycle with a relatively ineffective two-position control. The right act with the process that cannot tolerate. The continuous cycling of the proportional control is often employed with the process that cannot tolerate. Neither continue with the next cycling, no offset with the error with the proportional plus with the reset with the control. It can be used with the process that may be the involved. Proof stability can tolerate with the offset with the error with the proportional plus rate with the control. That is employed without with there. Some of the process that can tolerate offset with the error with the yet and a good instability. Logical solution to use with the control method combined with the advantage of the proportional reset and the rate action of the chapter to describe the mode. Identify the proportional plus reset plus rate, the commonly called the proportional integral derivative. The proportional plus rate controller action. The error introduced by the proportional integral derivative, the control of the controller respond with a combination of proportional integral directive actions is shown in figure 30. They assume they were sure what they do with this, logically increase the measure value of the error, then increase the proportional action of the proportional integral derivative. The controller produces an output of the proportional error, the signal the reset with the action of the controller produce the output with the whose reset with the chain with the determined magnitude of the error. In this case, the error chain of the continue with the increase the error rate, the reset output continue with the increase. The rate of change of the rate of action with the control of the produce the output with the whole magnitude, determine the rate of the change with the combined with the action produce the output shown in figure 30. Figure 30 show the error of the 0 to 5, 10% proportional action, only action 20 each percent the 0, 10% 20 reset action, only 0 to 5% rate of only action 80% 0 to 10% proper proportional plus rate output 30, 40, 55% time interval 1, 2 to 0 to 1 minute to 1 time interval 1 to 2 to 1 minute. As you can see from the combined action curve of the output of the producer, the respond immediately with the error with the signal, the proportional magnitude of the error that will continue to increase the long errors then remain increasing. You must remember the response with the curve of the drawing, assume with the corrective action, the take with the control system actuality, assume with the output of the controller begin with the reposition final control element, the magnitude of the error that should begin with the decrease. Eventually, the controller will bring the error to zero with the control variable back to the set point. The figure 31 demonstrates the combined control with the response with the demand determined proportional action with the control stabilize with the process of the reset action combined with the proportional action covered with the measure of the variable to determine the set point. The rate action combined with the proportional action reduce the initial overshoot in the cycle period. The demand as show the proportional plus reset and the measured variable the plus proportional plus reset plus rate and proportional plus rate. The proportional PID control mode and proportional plus reset control summary. The PID controller can combine the three individual modes to achieve the advantages of each. Proportional action will respond to the error amplitude. Integral action eliminates offset over the derivative action, provided the additional stability. The profit of the PID controllers can be the control profit most processes, even though those are difficult to control. Your controllers. The controllers are control the element with the control loop of the function of the magnitude of the profit, the variable, the pressure, the temperature level, and some of the desirable variable, the value may not with the be confident the machine accomplished with the varying setup with the signal desired value with the actual value with the control variable, the two value with the different with the error signal to produce the error signal amplify the creep of the string with the produce the control output signal with the output signal with the final control element of the alters the manipulated variable to return the control variable. The set point of the chapter will discover the two controllers commonly found with the nuclear facility control rooms. Although the plants may have other controllers, information presented here will generally apply with these controllers as well. The control station to perform the function of the control of the provide additional control with the indicator flow out with the operator with the manually adjust the control output with the final control element. The figure 32 show with the frontal pane with the typical control station with the containment with the several indicators control each will be discussed. Show the deviation indicator set point tape with the set point adjust the thumb wheel the final control element the operation tab with the snap name with the output meter with the manual output with adjusting the knob with the manual automatic transfer switch. The set point indicator located the design of the upper half of the control indicator with the set point with the desired variable with the desire with the set of the control with the slave with the measure with the 0 with the 100% corresponding directly with the control variable 0 to 100 psi gauge with the 20 degrees Fahrenheit to 180 degrees Fahrenheit. Set point adjustment located rate with the set indicator with the thumb wheel type with the adjustment is dialed with the allow with the operator to select with the set point value with the by rotating the thumb wheel with the scale move with the set point index line. The deviation indicator level located left with the point indicator displays arrow to plus positive 10% with the negative 10% with the set point value with the actual control of the variable no error deviation pointer state of the mid scale in line with the set point index mark with the control variable lower with the set point the deviation indicator effective downward higher indicator reflects upward example is shown in figure 33. This is a set point with 60% in process 60% zero deviation set point 60% in process 50% 10% deviation output meter horizontally position meter with below with the deviation set point with the indicator indicate with the control of the output signal the percent of the particular control of the range with the 0 to 100% of the current. However, the will respond to the air signal with the pneumatic control of the sap input tabs over each with above the output meter that indicate the direction of the final control elements are limited. Elements move the chain of the output signal with the normally right with the open close with the control valve slow fast variable speed motors and with the appropriate designation manual automatic transfer switch immediately below the outer meter selection operating mode control the motor manual output adjusting now with the manual automatic transfer switch varies the control output signal with the manual mode operation now with the rotated clockwise and the signal with the counterclockwise with the degree with the signal. The manual automatic transfer switch has 5 position alter the mode operation for the indication provided by the deviation meter. The normal position of the manual automatic transfer switch with the place if the control automatic mode of the operation off of the deviation meter indicate that any of the deviation between the control variable set point. The 0 to 100 auto side of the position of the controller is still automatic mode with the deviation meter now indicate the approximate value of the control variable. The deviation meter deflects the full down variable value full up to 100% of the value of the MAN, the position plate with the control of the manual mode, with the operation with the control of the output, with the variable, the adjusting of the manual output, adjusting now, shifting indicate with the outmeter, with the deviation meter, indicate the aim of the deviation between the control variable at set point. 0 to 100 manual side, but the controller still with the manual mode, with the operation with the deviation meter, indicate with the control variable speed of 0% to 100% did through 0 to 100% auto side position. B. Any BAL and indicate for the control outer signal the automatic mode manual mode may not be the same as the control variable directly transfer to automatic manual the manual auto automatic control automatic signal can suddenly change from one value to another as a result. The final control element that would experience with a sudden change of the position of the bump. This can couple the large swing of the value with the process variable to possible damage to the final control element. Bumpless transfer. The smooth transfer the control of the operating mode with note the balance of the position provided the smooth transfer of the transferring of the control automatic manual mode. Balance position controller still with the automatic mode operates by the deviation motor meter now indicate the difference between the output of the manual with the automatic mode with the control of the manual output of the adjusting of the until the deviation manual meter show that no deflection no now control can be transferred smoothly from the automatic to manual. To ensure the bumpless transfer of the manual automatic the manual output signal indicate the output meter to adjust the match for the control variable the value of the set point that indicate the no deflection deviation meter on the one match. Once the match the manual automatic transfer switch and can be switched to the manual or automatic control. Self-balancing control stations. Self-balancing manual automatic control stations. The figure 34 for the sum of the controls indicate the basically same with the zone with the manual automatic control station. Figure 32, however, the sum of the which would differ the addition controls effects does not require the balancing procedure prior to shifting of the one mode of the manual automatic to the other. So the set point indicator drum, the deviation indicator, set point, adjusting the thumb wheel, the manual push for decrease output, manual indication light with manual selection button, output signal meter, manual push for increase on output, and automatic indicating light automatic selection button. Alright, self-balancing, describing the control station with the non-operating with the mode with the output signal will follow with the track with the operating mode with the output signal with the control station with the automatic mode manual output signal will follow the automatic output signal with the control with the output. When the controller transfer the manual mode, the output signal will remain with the previous value with the until with the one with the manual push button with the discussed below with the output value will vary. With the controller's manual mode, the output signal will be tracked manually. Output signal the once for the controller transfer the manual automatic mode, the automatic output signal will initially remain with the manual mode value. The deviation it exists for the manual mode, but the automatic output signal will change the slow with the return of the control variable to set point. Deviation indicator adjustment thumb wheel and output meter with the control of the figure 34 with the function easily with the same as the figure 32 but the remain with the control with the indicator with quite different, therefore it will be discussed. The manual push button, the push button is located below each of the output meter with the U with the manual mode with the operation button with the located labeled indicator the effect with the final control element labeled the open close of the valve with the slow fast with the variable speed device the left push button with the creep of the output signal the right push button and creep of the output signal each of the button with the two different positions, the half in and full in, the half in position output signal change the slow with the full in position output changes and about 10 times faster. Alright, mode indicating light with the load located directly below the manual push button. These lights indicate the operating mode with the control of the manual mode with the left light with the label the manual will be labeled the automatic mode, the right label the label A will be labeled the mode selection bush and the load directly under each of the indicating light with each of the button will select the respective mode over the control of the button over the below with the manual mode of the light. The depressive control of the low will be the manual mode. The operation of the below the automatic mode over the mode light will depress the controller with the automatic mode of operation. As previously discussed, in particular, plane will probably have the controller differently with the two with the described and the here, but although the most information provided by the currently applied with extremely important with the operating known with the specific plane with the controller and their applications. Alright, final control element is all devices complete with the control link of the output with the controlling element for the process of the sense of the final control element designed with the specific application, for example, the neutron absorbed the control rod with the reaction to specify the design of the reaction, regulate neutron power level to have with the majority final control element with general application devices shift the valves, dampers, the pumps, and electrical heater valve, the damper that have similar function valve, regulator flow of the liquid while damper to regulate flow of the air with the gap of the pump like the valve that can be used with the control fluid of the fluid and current flow over the fluid. Here's are used to control temperature of these devices are being arranged to provide the type of the on-off control, maintain the variables between the minimum, maximum, and the minimum values. The accomplish opening and shutting the valve of the damper, the energizer, the de-energizing pump, the gears. On the other hand, the device can be modulated with giving an operating band to provide the operational control. This is accomplished positioning the valve of the damper, the variable speed with the pump, with the regulating with the current through the electrical heater. There are many of the options of the process control. The final control element is discussed most widely with the use of the power plants or valve. The valves can be easily adapted to control liquid level of the tank of the temperature for the heat exchange or flow rate. Some of the information controller summary. The set point indicator display the desired value with the controller dial adjust the U with the set of the point value with the set point adjust the deviation indicator of the display with the difference of the percentage before the set point value actual control variable value. Percentage display with the output signal indicator with the output meter with the manual automatic transfer switch with the live position switch for the alter with the manual mode located the center switch for the transfer switch manual output adjustment knob for the control output signal with the manual mode operations self balancing control station for the non-operating mode output signal is flowing to the operating mode output signal. Alright, your valve actuators. Actuators themselves, the valve cannot be proud of the manual valve required the operation position of the control process of the variable. The valve must be operated with remotely automatically require the special device to move them. Voices called our actuator. Actuator made they be the new hydraulic electrical solenoid motors. Show the housing, the diaphragm, mechanical strip, the supplying air connection, upper chamber, lower chamber, spring, local point, indicator, stem, the control valve. Alright, pneumatic actuator. Simplified diagram showing the pneumatic actuator showing figure 35. The operator for the combination fourth grade for the air spring for the actuator position for the control valve transmitting the motion through the stem rubber diaphragm separately the actuating from the housing of the two air chamber, the upper chamber, the receiver, the supply through the outputting of the top of the housing. The bottom of the chamber, the container, the spring with the fourth of the diaphragm again with the mechanical top of the upper chamber. Finally, low indicator with the connect with the stem with the indicator with the position of the valve, the position of the valve, the control of the variable, supply air pressure for the upper chamber with the result of the varying force at the top of the diaphragm, initial no air, supply air with the spring with the fourth of the diaphragm, up for the again with the mechanical stop, the hole with the valve, the fully open head, the sole apply air pressure for the increase with the zero with the air force at the top of the diaphragm, begin with the overcome the opposing force of the spring cover the diaphragm to move with the downward the control of the valve, the close with the increase with the supply air pressure the diaphragm will continue to move with the downward to compress with the spring until the control valve is fully closed. Conversely, if the supply with the air pressure decrease with the spring will begin with the force diaphragm to upward and open with the control valve eventually. Additionally, the supply pressure with the help of the constant sum of the value between zero and maximum value position and the intermediate position. Therefore, the valve can be positioned anywhere between full open and fully closed. Respond with the chamber with the full supply air pressure positioner is the device that regulates the supply air pressure pneumatic actuator. Definitely comparing the actuator demand position for the controller valve with the actuation position for the demand position for the transmit the pneumatic electrical control signal control of the position pneumatic actuator figure 35 of the figure 36 of the controller and position batter. The controller generated the output signal with the representative of the demand position for the signal the same with the position for the external position or consistent with the internal input, the connection for the control speed, the signal supply air input and connection to the supply air output connection with the supply air vent with the connection to the feedback link with the internal connection with the integrate network with electrical transducer air line with the valve with the link with the network necessary adjustment. Other positions made also provide control of the local valve positioning of the gauge with the indicating supply air pressure for the control air pressure for the pneumatic control from operator's viewpoint with describe the complex internal working the position needed. Therefore, the discussion will be limited to input the output from the position figure 36 with the control respond to the deviation control variable with the set point with the variable control output signal according to the correct deviation of the control output signal with the set with the position respond with the increase decreasing the supply air to the actuator position actuator control valve with the feedback of the position through the feedback link with the valve with the referred to the position demand with the control with the position stop with the chamber and supply air pressure hold with the valve with the new position. This turning correct with the controlled and variable the deviation from the set point. This shows the supply air out, the actuator, the supply air vent, the supply air vent, the feedback link with the controller output signal control valve. For example, if the control with the signal increase the valves into the position admitters with more simply air with the actuator, the result of the control valve moves down with the linkage transmit the valve with the position information back to the position of the form of the small internal feedback loop of the actuator valve reach of the position of the correlate with the control signal with the link stop the supply of the airflow of the actuator the cover of the actuator stop. On the other hand, if the control signal decreases no value inside the position open and allow the supply of the pressure to decrease the handling of the supply of air this cover the valve just move upward and to open the also have the open proper position stopping venting air from the actuator stop the movements of the control valve is an important safety feature of the provided the spring action in an actuator design with the position of the control valve safe position lows of the supply air curve the on the loss of the supply air with the actuator figure 36 value open the tape of the arrangement refer the air to close the air spring open simple fail open small valve the fail in the closed position. The typical type of the actuator referred to the air open spring to close fail close the fail save the concept of the important consideration of nuclear facility design. Hydraulic actuators. The pneumatic actuators normally use the control of the process of the requirement to quickly actuate response that does not require the large amount of the motive force. The output of the large amount of the force required the operating the valve. For example, the main steam system valve, the hydraulic actuators normally use although hydraulic actuators come in many design piston types are most common. Typical piston type of hydraulic actuator shown in figure 37 is considered the cylindrical piston spring with a hydraulic supply with the return line stem of the piston slides vertically inside of the cylinder separate the cylinder into the two chambers. The upper chamber that contains the spring and the lower the chamber that consists of the hydraulic oil. The hydraulic system contains a return line with connected with the lower chamber that will allow the hydraulic fluid to flow from the lower chamber to the actuator stem and transmit the motion of the piston to the valve. Figure 37 of the hydraulic actuator. The control valve, the stem, the hydraulic supply, return line, hydraulic fluid, piston, cylinder, and spring. Alright, initially with no hydraulic fluid, pressure for the spring force, hold the valve with a closed position, fluid, aim for the lower chamber, the pressure for the chamber, the the pressure, the result of the force for the bottom piston, opposite with the force caused by the spring. When the hydraulic force is greater than the spring force of the piston, begin to move upward, the spring with the pressure of the valve spring begins to open the hydraulic pressure, increase the valve with the country for the opening conversely with the hydraulic oil train. Strengthen and similar hydraulic force becomes less than the spring force of the position, move with the downward, the valve with the collar closes, regulating the amount of the oil supply drained with the actuator, the valve that can be positioned between the fully and open and fully closed. The principle of the operation hydraulic actuator are those pneumatic actuators. Even if they use some of the motive force to overcome the spring of the force of the motor, the value of the hydraulic actuators can be designed to fail open, fail close, provide fail safe feature. Electric solenoid actuator, typical electric solenoid actuator shown in figure 38 consists of the coil, arm, springature, and stem. Show the housing, spring, coil, and the armature, and the stem, and the control valve electrical connections. The coil is connected to the external current supply line, spring ref of the armature forward with the downward, the armature move vertically inside of the coil with the end, and transmit the motion through the stem of the valve, the current flow with the coil, magnetic field, the one with the round of the coil, magnetic field, the right stroke of the armature toward the center of the coil, armature move the upward with the spring with the collapse of the valve, opens, the trigger opens, and the current stop with the flow of the coil with the magnetic field collapse along the spring to expand the shot valve. Major advantage of the solenoid actuator, the quick operation that is with either the install of the pneumatic and the hydraulic actuator. However, the solenoid actuators have the two advantages. For the first half, they're only two positions, fully open and fully closed. Second, they do not produce more force. They use the only operative relatively small valves. Electromotive actuators. Electric motor actuators vary widely on the design application. Some of the electric motor actuators designed to operate with only two positions, fully open and fully closed. On the other electric motor, the position between two positions. Typical electrical motor actuators shown in figure 39. The major part of the include the electrical motor clutch, gearbox assembly, manual, hand wheel, and stem connected to the valve. This show figure 9. There's the electric motor actuator, processing pipe, control valve, processing pipe. Local position indicator, clutch and gearbox assembly, hand wheel, electric motor, terminal box, and position indicator device, clutch handle. The motor moves the stem of the gearbox, some of the motor reverses the rotation, either the open cover of the valve, the clutch and clutch level to disconnect with the electric motor from the gear with the assembly level of the valve to be operated manually by the hand wheel. Most electronic motors are equipped with the line limits with torque limits and bolt limited. Switch the energy of the electrical motor within the valve to reach the specific position torque. Limiters for the energy of the electric motor mounted with the turning force of the reach for the specified valve with the turning force normally greatest for the valve with the reach for the fully open, fully closed position. Feature can also be prevent damage to actuator valve with the valve binding to the intermediate position. The important information of this chapter is summarized below. Our valve actuator, some of the pneumatic actuator utilized with the combined and spring force with the quick actuator that respond with almost any type of the valve position ranging from 0 to 100%. Hydraulic actuators use fluid displacement with the position of the cylinder position of the valve and either 0 to 100% of the fluid flow. The type of the actuator incorporated with a large amount of force with the necessary to operate the valve. The solenoid actuator uses a small valves that apply the electromagnetic move of the stem, which allows the valve to either be fully open or fully closed. Equipped with the limited switch for the torque limited electrical motor actuator capable of the 0 to 100% control. Has now not only a motor but also a manual, hand wheel, clutch, and gearbox assembly. End of text. This was your let's say the Department of Energy Fundamental Handbook Construction Instrumentation Control Volume 2 of 2, U.S. Department of Energy, Washington, D.C. 20585. Distribution public for proof for public release. Distribution unlimited.